Hello everyone. Now that we have an idea of how we can create angles and how we can measure them and classify them, now we want to go ahead and talk about the relationship between them. And what we're going to do is we're going to take a look at particular angles and breaking them up into separate parts and looking at the relationships there, as well as looking at relationships between angles that are formed when lines are involved. So let's first take a look at what happens when we're given an angle and we divide that angle into two angles. So for example, let's go ahead and take a look at this particular situation, which is called complementary angles. Now the initial statement says that theta plus alpha is equal to 90 degrees. So basically what we're going to do then is we're going to take a right angle and then we're going to separate it or cut it up into two different angles. And so here what I have here is a diagram of a right angle. And if I go ahead and cut it up in any way that I want, then what I create is another angle called theta and another angle called alpha. And now notice that what happens is that when I add those two angles, of course, it's going to be equal to 90 degrees. So what we say in that situation is we say that theta and alpha are complementary angles. And what we say mathematically is that theta plus alpha is equal to 90 degrees. Supplementary angles act in the exact same way. If we go ahead and take a look at a straight angle, say for example here, straight angle, and if I go ahead and divide that straight angle into two different angles, so again here is theta now, and here is alpha, then what I know is that if I add those two angles together, I'm going to come up with 180 degrees. And so that's the initial statement for supplementary angles, and we say that theta and alpha are supplementary. Now, angles at a point, what does that refer to? Notice that we talked about right angles. This was a straight angle. This is a full rotation. So if we take a look at a full rotation here, and I was to go ahead and subdivide that full rotation into two parts, then I can say that this right here is theta, and that right there is alpha. So then if I go ahead and add theta and alpha together, it's going to come out to 360 degrees, which is what the initial statement says. So we know that the angles at a point, theta and alpha, when added together, will give me 360 degrees. So let's take a look at an example here. Here's the diagram that I have, and it says find the measures of the four angles that are there. We have A, 2A, C, and D. Now, if I wanted to go ahead and find A, of course, if I look at A and 2A, I know that that's going to form a right angle. So therefore, I know that 2A and A are complementary. Therefore, what I can say by using the initial statement is that theta plus alpha is equal to 90 degrees. I'm going to assign theta to be 2A and alpha to be A. So I know that 3A is equal to 90 degrees and A is going to be 30 degrees. Now, in order to find C, I'm going to say, well, if I take a look at C, C involves this angle here and that angle there, which form a straight angle. Therefore, I can say that 2A and C are supplementary, which means then mathematically is that theta plus alpha is equal to 180 degrees, where theta is going to be 2A in this case, and C is going to be equal to alpha. So I know that A was 30 degrees, so 2A is going to be 60 degrees plus C is equal to 180. Subtract 60 from both sides, and I know that C is going to be equal to 120 degrees. Now to find D, I could probably go ahead and use the same approach here with the angle D and A and say that those two angles are going to be supplementary to each other, which they are. But just to go ahead and show how you can use this particular initial statement as well, I'm just going to say, well, if I go from A to A and C and consider that one angle there plus D are going to be considered an angle at a point. So what I can do then is say that theta plus alpha is going to be equal to 360 degrees. And notice that 2A plus C, which is going to end up to 210 degrees plus D has to be equal to 360 degrees. If I subtract 210 from both sides, I know that D is going to be equal to 150 degrees. Okay. So that's what happens when we can take a particular angle that's given to us, and if we divide it into two separate angles, then of course we can come out with these relationships. Now, what happens when we go ahead and take a look at angles that are created by lines, intersecting lines or even non-intersecting lines? Well, we're going to have to take a look at two situations. One, where we're dealing with non-parallel lines, or in other words, lines that intersect each other. And we're going to take a look at parallel lines and what is called a transversal line, which means that two parallel lines, which of course don't intersect, and then you have a transversal, which is a line that's going to intersect both of the parallel lines. And what kind of angles are therefore created. Now, if we go ahead and take a look at, say, for example, the non-parallel lines, in other words, we're going to create then what is called vertical angles. Now, what I have here is a situation that actually fulfills both of these, okay? Because if I just go ahead and just look at that top part, then that top part are two intersecting lines. I have this line here and that line there. And what's going to happen is that when I have any two non-parallel lines intersecting each other, they are going to create what are called vertical angles. Now, the vertical angles are going to be equal in measure. Now, let's just say that we focus just on this part here. If we focus just on that top part, the vertical angles are going to be A and C, which are right across from each other here, and B and D, which are right across from each other there. Those angles are going to be equal in measure. Now, if we go ahead and talk about parallel lines, so I'm going to introduce another line here, which is parallel to this line here, and notice I'm using the notation to show that it's parallel. Then what I'm going to say then is that this line here now is going to be called a transversal, because it is cutting pairs of parallel lines, or more than one pair of parallel lines. And so what I'm going to create then is I'm going to create all of these different angles here, and notice I've labeled all of them from A to A, B, C, D, E, F, G, H to H. And what's going to happen then is that we're going to be able to create what are called corresponding angles, alternate interior and exterior angles, as well as co-interior and co-exterior angles. And the relationships we need to remember are these. When we're dealing with corresponding angles are going to be equal in measure. When we talk about alternate interior or exterior angles, they are also equal in measure. When it comes to these angles, which ones are they? Now, if we go ahead and talk about the corresponding angles, the way that we need to look at this are these four and these four. So when we say that they're corresponding, their relative location has to be the same. So what I'm going to say then is that A corresponds to E, and therefore A is equal to E in measure. B is going to correspond to F, angle D is going to correspond to H, and angle C is going to correspond to G. So that's how we go ahead and talk about corresponding angles and saying that those angles are in fact equal in measure. Now, what about the alternate interior and exterior angles, which are also equal in measure? Now, the alternate interior, well, which one of these are actually interior in this case? Well, when we go ahead and take a look at this, the interior ones here are D, C, E, and F. The exterior ones are A, B, H, and G. Now, when I say alternate interior, well, let's go ahead and focus again on the interior ones. Here are the interior ones. When I say alternate, what comes to mind? Alternate means this, it flips, So what that means then is that if I go ahead and talk about the alternate interior angles, I'm talking about C and E, or I'm talking about D and F. Those angles will be equivalent or equal in measure. The same thing exists for the exterior angles here, A, B, and H, G. If I go ahead and talk about the alternate exterior angles, then A would be alternate exterior to G, and B would be alternate exterior to H. And those, again, would also be equal in measure. Now, when I go ahead and talk about the co-interior exterior angles, the co-interior exterior angles are the ones that are on the same side of the transversal. Notice the alternate one says alternate between sides of the transversal. The co-interior exterior means that you need to stay on the same side of the transversal. So what that means then is that these angles are going to be supplementary in measure. So let's go ahead and take a look at the interior angles again. These are the interior angles. If I was to go ahead and talk about the co-interior angles, I'm talking about this pair, C and F or D and E. Those pairs are supplementary. In the same respect, if I talk about the co-exterior angles, here are the exterior ones again. B and G would be co-exterior. A and H would also be co-exterior angles. And again, those pairs are supplementary to each other. Now let's go ahead and see how we can apply these relationships in terms of the problem. So let's say, for example, that we know that F here is equal to 3A. Could we actually go ahead and determine what the value of A is? And the answer is yes. Now what we're going to need to do is notice that we have a lot of algebra here, but in addition to that, it's going to be important, being that we're dealing with certain relationships, to go ahead in parentheses next to the statement, provide a reason. So for example, we know that A is equal to C. Well, why is A equal to C? Because A and C are vertical angles. Okay? Now we know that C and F are supplementary because co-interior angles are supplementary. Now if I go ahead and say A plus F is equal to 180, that makes sense because we've substituted A for C. Okay? And then notice that what we've done is we've also substituted 3A for F because that's what it said here in our original problem. So now we can go ahead and add these two, say 4A is equal to 180, divide both sides by 4, A is going to be equal to 45 degrees. Okay, so let's kind of wrap things up again. We've dealt with angles on their own, and now we're going to have to take a look at the relationships that are created by angles and lines. So we know the complementary, supplementary, and angles at a point are created when we go ahead and take a look at a particular angle, a 90, 180, or 360 degree angle, and split them up into two parts. We also know how angles now are going to be created by intersecting lines. We have the non-parallel lines that are going to intersect and create vertical angles. And we also know what's going to happen when we have parallel lines that are going to be cut by a transversal that are then going to create 8 separate angles. And we're going to be able to actually see the relationships depending upon whether we're dealing with corresponding angles, alternate exterior or interior angles, co-exterior or interior angles. And it's going to be important that we remember those relationships there, so that when we come across situations like this, we'll be able to go ahead and solve for particular values of the angles, providing that we know what the relationships are and that exist within the diagram itself. Okay. So we will go ahead and take a look at some of these problems the next time that we are in class together, and let's see how we do. Okay? See you later. Bye-bye.